yeah, I'm going to talk about control planes, event streams, federation, three things that I'm personally very interested in, that I think as a company we're very interested in and excited about in 2024. So just a quick word about me. I'm Jonathan Michaux. I'm a product manager at Gravitee. We're an API management company. We are a new entrant in the Gartner Magic Quadrant for API management as just last year, so very exciting. I live in Nantes, France, which is the location of this iconic mechanical elephant. So, you know, in Texas, we ride the mechanical bull. In Nantes, we ride the mechanical elephant. It's way more chilled out. It doesn't throw you off, but it does spray you with water every now and then. I've been in the enterprise middleware space for about 10 years across different areas, and I'm also co-author of this Kubernetes cookbook that came out last year, so a lot of fun. So yeah, I want to talk about a couple things that I think will have a big impact in 2024 and beyond. Just sort of trends and themes, things that I think might be useful for you all to think about, which you probably are already thinking about, and some people have mentioned already at the conference. So I just want to start by talking about complexity. So whether you're an API center of excellence, an API platform team, you're dealing with a lot of complexity today, and things aren't really getting simpler. So what do I mean by that? If you look at just the team structures, the distribution geographically of people that are using API management today, it's getting more complicated. People are deploying APIs across different clouds, across different platforms, SaaS, on-prem. The volume of APIs is growing from tens to hundreds to thousands, and we see that kind of volume regularly. You might be dabbling in new types of APIs like GraphQL or asynchronous APIs. There's the time dimension. So overall, I think it's interesting to just take a step back and think about why we do APIs. It's to create an abstraction on top of all this complexity so that you hide all the complexity under the API, make life easier for the developer that's consuming them, present them with a uniform, consistent interface that's kind of stable over time, right? So that's kind of the job of an API, really. Businesses can then get more agility, more velocity. And what I want to talk about today is how some of these elements of complexity I just mentioned impact what a modern API management solution needs to look like and how it needs to work. So technology exists to serve the interests of people. It just so happens that people get into very complex organizations to do what they need to do today. So this diagram just shows an example of a team organization that a prospect of ours or customer sent to us one day and said, this is how we want to organize our teams. And so we all looked at each other and said, whew, that's pretty complicated. So they had 20 teams, essentially, independent teams, and they all wanted to have self-service access to API management. So this puts a bit of pressure on an API management vendor to think about how you can solve this. They didn't want to have one dedicated stack for every team to share because that would just be too chaotic. Having an individual stack for each team would be too expensive. So they needed to have this kind of idea of virtualized environments for each team. And each team would be sharing sets of control planes and data planes in order to control costs. And all this with just the right amount of centralized governance. So what complex organizations need is a flexible, multi-tenant API management solution. I think we live in a multi-tenant world today. Clouds, all this kind of stuff, multi-tenancy is key. Governance teams need a centralized model to help them rationalize about all these things that they have to manage, but each individual team member needs an isolated environment that they can work in. And you also want to be able to choose from different operational models. So some things you want to be able to run in the cloud as SaaS, some on-prem, some hybrid. It's interesting to think about just putting as much as you can into a SaaS model to simplify your life, but then everything that needs to be handled on-prem, you can do that as well. So yeah, multi-tenant API management matches a complex organization's structure without breaking the bank. That's the general idea. But this doesn't really explain how each individual team is going to be empowered to do self-service API management, like I mentioned before. So this is where I want to talk about another trend I find interesting, which is platform engineering. So I think just before some people were talking about platform engineering a little bit. Little prediction, I think maybe to some degree already obvious, which is that the synergies between platform engineering and API management will flourish over the next year, already are flourishing to some degree. So let's unbundle this a little bit. Platform engineers are generally trying to improve two metrics. One is developer experience, and the other one is time to market. So how quickly can developers build their software and release it? This is often done by enabling developers to self-serve, because that's how they can act quickly. But you still need to provide guardrails so that what they're doing is under control. And the output of platform engineering is a developer platform, an internal developer platform. So according to Gartner, 80% of large software organizations will be building internal developer platforms by 2026. And from what I'm seeing, I'm definitely seeing a lot of that. So API management isn't typically the first thing that comes to mind when you think about internal developer platforms and platform engineering. But I think the principles make a lot of sense for API management. So if we break that down a bit, I think there are two big interpretations. So the one we hear the most about is that platform engineers are themselves API consumers and API producers. So if they think about APIs as products, they can reap the benefits of platform engineering. But there's one approach which is less talked about, which I think about a lot, which is that platform engineering can actually enable API publishers to do self-service API management. So not just general developers, but API publishers themselves. So let's double click on that idea for a second, and I'll show you what I mean. So at the bottom here, you have your API management layer, which is made up of control planes, so user interfaces to configure APIs, CLIs, APIs, data planes, the gateways, and then APIs are distributed across those based on certain criteria, like is it a dev environment, a production environment, or based on teams. The API platform is like a new layer on top of API management, and its role is on one hand to abstract away the complexity of the control planes and data planes. You can sort of see them as like the infrastructure, which is a bit lower level. And on the top, it focuses on enabling internal teams to self-serve API management. So the end users of this platform, because every platform is built for a specific end user, the end users are API publishers, right? The people who want to build APIs, because there are more and more of these in every organization spread across the company. So the benefit here is that API publishers don't need to manipulate control planes and data planes themselves by hand, which is complex operational stuff that takes a long time to do. And they don't need to just sort of open a ticket in a big backlog for a DevOps team to instantiate an environment for them. The idea is they're empowered to do it themselves. So we call this API platform engineering. And it's, again, if we think about what are the outcomes you can achieve by doing this, you can improve the time to market for API projects, and you can improve the developer experience. It's always nice to think about KPIs, like what could you measure to know if you're doing something like this right. So one thing is, how long does it take for someone to provision a new control plane or a new data plane? So let's say you start up a new team in your company to work on a new project. They might want their own instance of this API management platform you're using, whatever it may be, and their own gateway, or 2 gateways, or 2 control planes and 3 gateways, whatever it might be. How long does it take for them to do that? And are they able to do that? And can they deploy it wherever they want? The other one is just how long does it take for them to actually provision their own APIs? Same deal, Can they do that in an automated fashion, in a self-service fashion? So this is all nice, and I think everyone would love to improve these kind of metrics. The question is, how do you actually do it, right? So platform engineering is, it's a form of engineering. There's no out-of-the-box solution that will solve every organization's needs for this. So the platform is like a product. It needs to be built. It requires investment. But there are ways to accelerate. And so this is another angle I want to talk about, which is GitOps for API management. So again, something people have talked about at the conference, which is great. So I think if you're deploying hundreds or even thousands of APIs and you're not using GitOps, you're probably reinventing the wheel somewhere. So let me dig into that a little bit. So if you're deploying hundreds of APIs, you're necessarily doing automation somewhere, right? You're not just clicking in a UI and building hundreds of APIs and doing that every single time. At least I hope so for your sake. That automation itself can be some pretty sophisticated software engineering. That can be a pretty complex thing. You need to determine, what is the source of truth for the configuration of these APIs. You need to automate their deployment. You need to manage any drift between the state of what's running live and what you actually want as a target state. You need to enable collaboration among teams so that they can, collaborate on APIs and deploy them. So that's a lot of engineering, ultimately. And so, I speak regularly to companies who are doing this sort of thing. They've got hundreds of APIs, and they tell me about all the work they're doing just to handle all these problems. They're building complex pipelines. They've got scripts. They're doing all kinds of automation themselves. But there are common patterns, and I think GitOps addresses a number of these patterns in a sort of fairly standard way, and it can save you engineering cycles. So if you think about GitOps for API management and how it works, basically the idea is that you're going to have Git repositories, or any kind of version control repositories, and the way you break this up is up to you. You might have one per team, you might have one per environment. There's no real rule on that. And the way that changes are made to your API management layer, so whether that's creating a control plane, creating a data plane, creating APIs, is through something like pull requests to a Git repository. So pull requests encourage developers to do reviews on what's being changed, so it fosters collaboration, and that's definitely a great thing. GitOps is often paired with Kubernetes, so it doesn't have to be, but it is in many cases. And so just to break down why that is, Kubernetes is like a platform for building platforms. You may have heard people say that before. And if you look at API management vendors that are kind of committed to the GitOps approach, and there are a few of them here at the conference, they often provide operators for API management on Kubernetes. So the operator is an abstraction that runs on a Kubernetes cluster and handles a bunch of heavy lifting for you, like, for example, deploying control planes, deploying data planes, creating APIs. All that work is bundled into this thing called an operator, so you don't have to think about how to do that. So the next step in GitOps for API measurement is the continuous deployment pipeline. So tools like Argo CD or others will be watching the Git repository for changes. If something changes, it can pull the latest version and then apply that to the cluster by talking to the operator and saying, here's a new version of an API. And then the operator will look at the state of the Kubernetes cluster, see if everything is in the right state or not, and reconcile that based on what you've asked it to do. And so same thing in Kubernetes, you can then either have a cluster per team or a cluster per environment or namespaces inside a cluster. There are many ways you can break that down depending on how you want to share resources or create isolated tenants and that kind of thing. So this is a declarative approach. All of your configuration is defined as code or essentially as text, structured text in a Git repository. And if you can, there is a bit of effort to get to a solution like this, but it will allow you to write less of that automation code that you may have had to write yourself. And so if you can do this well, there are benefits to repeatability. So you can easily create a new instance of an environment just by applying what you did for the previous one. You can roll back. You get more reliability because there's less manual error. There's less automation that you're writing yourself. Independent teams should be able to get a lot of autonomy, but with minimal cross-interference across teams. So that's a bunch of stuff that I think makes up what a modern API control plane is starting to look like. If we take a step back, I want to talk about one other dimension of complexity which is faced by API teams. Another one we've heard about a bit today at the conference, which is that organizations are more and more subject to the proliferation of gateways and brokers. So what I mean by this is today, so maybe if I go back 10 years to my first API Days conference in 2014, people were just looking for their first API management solution. Now every conversation I have with the company is, well, we have Apogee and we have the Kafka, but we don't have a way to manage them all consistently. And it's amazing just how many organizations have this problem, and there isn't really a very, very clear solution today. I mean, people are working on this. Gartner's talking about it. We had other companies talking about it today, but it's still fairly nascent. The cause of this is possibly that you've grown through acquisition. You bought a company that was using Azure and you're on AWS, whatever it might be. You might just be doing multi-cloud for intentional reasons. You might be migrating from one technology to another. But basically, you end up with APIs and event streams in different places in different form factors. So this is common today. The problems that it causes is that it's very hard for a developer that joins an organization that has all these things to figure out how to build an app that consumes these systems, right? I talk to companies that have very sophisticated, very smart development teams, and developers join the company, they onboard, and they say, well, I heard we have some useful APIs on AWS, but I just don't know where they are, who to contact to get access to them. So what do you do about that? It's really painful. And it's also, for governance teams, hard to understand who's accessing these systems, who's using them, and how much. So an interesting thing, I think, which is also pushing for this trend around federation is that there's a bit of commoditization in terms of what gateways actually do. Like, you don't hear that much about, oh, we released this new policy for our gateway. Most gateways have a standard set of policies these days, rate limiting, authentication, some transformation. So that's becoming a bit of a commodity. There's also a bit of commoditization about how vendors allow you to publish groups of APIs into things like API products or usage plans. So these are all kind of common terms that you find now across many different vendors. So this creates an opportunity as you sort of get commodity and uniformization in these kind of features. There's an opportunity to see what we can do about sort of unifying all of this. So federation is what I'm calling it. Multi-gateway. There are different terms, but I think it's emerging as an interesting path for this. So to embrace this diversity, to capitalize also on these existing investments, because it's very hard sometimes to drop one of these platforms if you've got so much invested into it. I heard a really interesting metric from a company recently who were interested in this kind of stuff, and the guy said to me, my metric for 2024 is to reduce the time it takes for a developer in the company to subscribe to an API from a month to days. And that's literally his OKR for the year. So interesting to think about the impact that can have if you can sort of centralize these things into a control plane and to a developer portal that abstracts away all that complexity for the developer that just wants to build applications. So yeah, the idea behind federation is to unify these common elements from different providers into a unified control plane. It's not easy to do. I mean, even though we do find similar policies in all these different platforms and similar concepts, it's still a hard task. So that's why it's a nascent thing. I don't think anyone has completely solved this yet. You'll find people that are working on it, but it's an interesting opportunity, but also quite a challenge. But if you can do it, the benefits are great. Publishing APIs from different vendors into a single developer portal. What's important to note is that under the hood, these kind of solutions are not actually proxying traffic at runtime. They're helping you unify documentation. They're helping you handle things like subscription management. But under the hood, they're delegating to that third-party provider. So the actual application is just hitting AWS, Apigee, Azure, whatever it might be. So one final dimension of complexity I mentioned earlier that I want to talk about, and this is something that we're really into at Gravitee. You may have heard us talk about this before. I'll start with just an example. So this is a stock market application we use as an example for a demo. It's basically got stock tickers. It's giving you updates in real time about stock prices. You can purchase stocks, you can sell stocks, and everything's updating and dynamically and in real time. And actually, the backend that's powering all this is a Kafka broker with a bunch of event streaming and processing. So a lot of companies have some form of real-time data, right? I'm sure lots of you know that there's a team in the company that has a Kafka broker or some other event-driven system that's doing something interesting and valuable. There are probably some really interesting data or events in there, some insights to be had. But how do you make these available to developers? That's one of the challenges we're seeing today, is that it's just not as easy to give these systems to developers so they can integrate them into their applications. What's hard is, for example, if you say to a developer, hey, we have a stream of events on this thing you're interested in, but you have to consume a Kafka topic to do that. So it's possible. There are companies that do it. It's not necessarily a bad thing. But if you're a developer that's not used to doing that, if you're just used to consuming APIs, building a Kafka client into your application can be a bit tricky. You need to know a bit about Kafka, consumer groups, offset management. There's a lot of stuff to learn. It's also hard to govern. So I've heard many stories of companies with big Kafka clusters with topics all over the place, and they don't really know who's using which topic, what events are in each topic, and so they can't remove topics because they don't know who's using them, and you end up with this kind of a bit of a mess. So governance on these systems can be very hard. So yeah, this example front-end application is not hitting Kafka directly. It's using the Gravitee gateway, which is mediating the Kafka protocol and turning that into, I think we're using WebSockets here to push updates to this web application. So that's what we call event-native API management. It allows you to manage traditional APIs, REST APIs, and event-driven APIs side by side in a unified way. It requires connectivity, so you do need to be able to connect to all these message-driven systems, whatever they may be, and then you need to mediate those protocols. So you're doing Kafka on the back end or MQTT on the back end, and then exposing that as server-sent events or WebSockets or webhooks if you want to keep it simple, or even just as REST. So you can do a GET request and read from a Kafka topic, for example. So that's how we built the stock trading app I just showed you. And yeah, that's a big part of our vision for unified API management. Cool. So yeah, just to bring it all together, a few interesting things to look out for this year, and that I know we're certainly interested in. Control planes. I'm using the word control planes here, but there's just a lot of new requirements emerging for how to handle API management in a big company. Multi-tenancy, API platform engineering, GitOps. Federation, I think, is also something to keep an eye out for. There are many people who just have all these different brokers, event brokers and gateways in their IT, and they want to be able to unify them, govern them, and capitalize on those investments, because some of them are just multi-million-dollar deals over years, and you can't just rip them and replace them. And the last one is events. So I think events are going to be increasingly seen as first-class citizens in API management, not just something that's kind of completely different. And that requires a bit of mediation in certain technologies, but I think at least what we're seeing is that it's possible and that it's desirable, and so I think we're going to see more of that over the year. So that's it from me. Thank you very much.